All right, hi. So we didn't really want to give an update until we had some news about the bus painting. And so we actually did get some news just a couple days ago. We got a text from our painter that said, hey, great news, we're starting to spray. And so we didn't really know how good of news that was because we got the hey great news, we were ready to strip 2 months ago. So anyway, it turns out that the actual spraying of the bus is sort of the final step. So we're in the very last transition. So hopefully maybe within the next couple weeks we'll actually have our bus back. So as many of you guys know, we delivered the bus sometime in mid-June, and so it's been about just right at about 3 months, just a little over 3 months actually, since we've delivered it. And so we're really excited that there's finally light at the end of the tunnel, and we'll be getting to it. So he did actually say that it was a lot more work than he had anticipated. The fact that it had so many layers of paint, he said. It had the original factory paint and then maybe a couple of other paintings on top of that. And so he didn't feel right without stripping it all the way down. So he took it all the way down to the bare metal and then resealed everything and then fixed all the panels and heavy primered everything and sanded everything smooth. And so he said it's gonna look great when it's finished, but it was just a lot of work. That coupled with a couple of weeks ago, we had a headlight issue where the buckets behind the headlights were all kind of rusted out and just corroded. And so he said, is there any way to find new ones? And I thought, no way. So I called around, and it turns out we have a friend in California who had some. And so we bought those, and so miraculously that was taken care of. And so everything looks like it's a go. So we're super excited. He's starting to spray and all that stuff. So about 3 weeks ago or so, we finished the solar stuff, which you guys saw. And since then, we've had a ton of house projects. So we had an AC go bad, we had a pool pump go bad, we've had just a huge number of things just happen that we needed to take care of. And so one of the projects for the bus is actually getting this house ready and getting it ready to sell. And so that involves doing all of those sorts of things that, take the house to getting it ready to put on the market. And that means fixing all the little things, spackling the walls and fixing all the little issues that we've had. So we've been super busy doing that stuff. But what we've actually also done is started to dig into how are we gonna wire up the inside of the bus. And so we wanted to share that stuff. And this is nowhere near complete, meaning we haven't completely fleshed this all out. I'm titling this Bus Automation, but it's basically what we've learned about home automation and how that can apply to buses and what can be used and what can't, and what we've discovered and things that we've written off and some decisions that we've made, but everything is super preliminary. But we'll introduce some of the stuff that we've gone through and coupled with some of the technologies that we think we're going to plan on using. So let's get started. All right, so what do I mean when I say bus automation? So when I say bus automation, I mean trying to take some of the concepts from home automation, which admittedly is kind of in its infancy right now, and apply those to our bus or RV platform. And some of those things include being able to do scenes. In other words, let's say it's ready for nighttime. It would maybe turn all the lights off, turn the pump off, lower the blinds, things like that. There's a number of things that can be programmed where it does these things in a sequence. Same with, okay, it's time to get up. Now what's going to happen? There's a number of things that it could do. And so having a platform on which to do that, as well as being able to remotely monitor things. So say the temperature gets too high, it might set an alarm or it might automatically turn on the AC. So things like that. All kinds of things surrounding the automation of things that you can do at home, which involve having sensors and being able to detect different situations based on the sensor input, and control things either while we're there or remotely. So that's what I'm kind of getting at when I say bus automation. It isn't probably going to be a full-blown, like a home automation type thing, but it'll start to approach that. And the way it affects wiring is, traditionally, when you want to turn a light on and you have a switch, you have to have a switch which will then interrupt the power to the light. And let's say you want 2 or 3 switches. Well, then those switches now have to know about each other, and they have to know what each is doing and things like that. And so the original thought was, wouldn't it be cool if instead of running a bunch of wires everywhere, that the lights sort of knew that they were lights and could accept input from multiple things. So it could be on our phones where we tell it to turn on the light, or it could be that we hit a switch, or it could be that it's 6 o'clock and it's time to turn on. Things like that. So we thought, wouldn't it be neat if we didn't have to wire everything everywhere, and we could just bring in sort of one master wire, and then that would then control the lights. Another thing is, we're going to have a lot of little LEDs, and wouldn't it be cool if we could maybe turn those on and off, maybe independently? Let's say you only need room light on the right side of the room, or you want to dim it, but not all the lights. And so that would require a bunch of different switches and a bunch of different sort of dimmer type things that would control each individual light. And that gets to be pretty messy without having some kind of like computer type interface. And so those kinds of things led us down this road of, wouldn't it be cool if we could sort of program this stuff? That's like what I do for a living. So wouldn't it be neat if we could try to apply those same concepts to the wiring in our bus? And that would reduce on wiring. If I, imagine having, let's say we have 10 lights just in the front area. Now I need 10 switches and 10 dimmers, and I know they make things that make that a little bit smaller and more manageable, but you still have to run all those wires. So wouldn't it be cool if we could solve that problem in a neater way? So that this is kind of our attempt to address that issue. Okay, so some of the products that we started looking at first are more traditional home automation type products. So there's a series of products that are designed to make your home into a smart home. And one of the more popular ones is this Samsung SmartThings. And so we thought, hey, why don't we give that a try first? A lot of my friends use these and they're pretty happy with them. And so it happened to be on Amazon and it was on sale and it was like $100 off or something. And so we actually bought one of these. And as you can see, we haven't even opened it because as we researched more, we almost wrote this one off almost immediately because one is this system really depends on having 120 volt AC power. And so, as you know, most bus lights, RV lights, things like that are 12 volts. And so we were going to have to hack something to get this to work anyway. We also learned that most of the automations and the triggers and things like that require an internet access. In other words, they require commands to actually go out into the internet, then come right back in, even if you're local. I know they've changed some of that stuff, and that stuff is constantly being improved and things like that, but when we were kind of looking into this, that was the primary mode of function, especially for automation. So automations actually come from the web, and they, or the cloud or whatever you want to call it, and they hit this device, and then that triggers things to happen. And so if one of our primary focuses is to boondock, we may not necessarily have a strong connection. And how frustrating would that be that none of our automations work, or we can't turn lights on and off from our cell phones if we don't have internet access? So this was almost a no-go right from the beginning. We also got just some switches to just play with and to see what this whole thing was about and what we could do and how we could use those things and how we could leverage them. But like I said, this we almost wrote off immediately, just because it was going to be so hard to make it work that we just didn't really think it would be worth the effort. So the Samsung Smart things, unfortunately, we had to write that off almost immediately. All right, so after we had kind of gone through that whole thing and decided not to use sort of a commercial ready to go kit, what I actually decided to try to use was, this is a Raspberry Pi. So this is essentially a very small computer, and they're actually quite powerful, but it runs a Linux operating system. And what if we could use this as a server to then trigger automations and do things like that? Well, there's an open source project called Hass.io, or it's just called Home Assistant, and it's completely open source, and one of its focuses is on privacy, and that was a big concern with some of the other ones because everything is coming in from the outside. We kind of were like, well, how much information are we letting in? And so one of the primary focuses of this Home Assistant is that it's all local. Everything is kind of on your own little network, and it allows you to set up lights and scenarios and group things the way we wanted to, but without having to have outside internet access. Now, there is a way to set up remote access to see what's going on and to see what lights are on and to see the state of things. So it kind of seemed like it would maybe fit our situation a little better. So we started to explore that. So the first decision we kind of made was, let's see if we can go with Home Assistant, and it seems to be a good fit. So now Home Assistant, however, is just a lot more raw than all the other things that we looked at. So Samsung and a couple like the Alexa and Google Home and things like that. It is just a lot less refined. And so you have to configure things in these text files, and it's a little wonky to work with, to be perfectly honest. But fortunately, we discovered there's this other technology called MQTT, and what it basically is sort of what I was describing at first, where the lights are sort of aware of themselves, and then a switch is sort of aware of itself. And so what happens is, when you flip a switch, it puts a message onto this bus that then says, hey, if you care about the lights being on, the lights are supposed to be on. And so then the thing that's like, oh, I'm listening for that message, can retrieve that message and then turn itself on. And so I'm going to try not to go into the technical details, but I know I sort of have the curse of information. I know kind of a lot about this, and so I'm going to try to keep it relatively high level so that it doesn't get too much in the weeds. But without going into too many details, it's essentially a message bus that you can put messages on, and then if you want to be aware of different messages, then you can listen or subscribe. So this is a publisher-subscriber model. You can subscribe to those things, and then they will be fed to you. So in other words, if I'm a temperature monitor, I probably don't care about anything else going on, but I will have an interval that I put things on the bus. So say every 30 seconds or every minute, I put a message on the bus that says, hey, the inside of the fridge is currently 38 degrees. And then a minute later, I say, hey, the inside of the fridge is currently 38 degrees. So you can see how that would be pretty boring. You open the fridge, hey, the inside is 40 degrees, things like that. And so then there's another thing that can listen to that and display it on a graph, or alert you. Let's say if the refrigerator temperature gets too high, if it gets around 45 degrees or 50 degrees, it can then send an alert that said, hey, you might want to check the fridge because the temperature is getting too high in there. things like that. Or if the inside temperature is getting too high, or if the humidity is getting too high, things like that. So these things just put messages on the buses, and then things that care about them will listen, and then you can set up automations based on some of those input values. And so that is one of the most exciting technologies that we discovered, was the MQTT. Unfortunately, that's a little bit cumbersome to use as well, and so we made another discovery that uses this other technology called Node-RED. And so Node-RED kind of ties a graphical interface with these events, and so you can program automations almost with like a drop and drag type of interface, where it says, hey, if this message is present, then I want you to do these 4 things. And so that part was really cool. We haven't really played with that stuff too much, but the MQTT server would run on this same device, as well as the hub, if you will, for Home Assistant, which is the home automation portion of that. And so then we were left with, okay, now, since we're kind of starting from scratch, how are we going to get input? Or if I hit a button, how is that going to then put a message on a bus and things like that? And so for that, we discovered that we could use, so this is just an Arduino, and this is a full-size one. This is actually a Mega, which has way more inputs and outputs than, say, like a typical regular Arduino. We discovered that there's a piece of software written for this that you can literally say, hey, write this message to the bus, or listen for this message, and then this can react and do certain things. So this is the interface. So you would put one of these everywhere where you need an interface. So the problem then becomes, these don't have like Wi-Fi, and so you would have to then, we're back to wiring things back in. Well, the next step was discovering that there are very inexpensive Wi-Fi chips, and so that is what this is. All right, so this is what's called an ESP32, and it's basically just a chip that has a bunch of pins, and each of those pins can act as an input or output. And it has a full Arduino stack, as well as Wi-Fi and Bluetooth. And so there's just a load of features on these that you can use to trigger sensors or to accept input from sensors. And the Arduino community is huge on writing drivers and things for motors, as well as like different sensors and things like that. So you can use these to feed, and there's libraries written to write to an MQTT bus. And so you can either listen or put things on that, and then you can wire one of these up to like a switch that controls multiple things, or a sensor that controls things, or any number of things like that. So these can't take a ton of voltage directly. They're mostly for logic, and so when you have to then go out and do things in the real world, then you need a relay board. So a relay board is basically just a board with a bunch of inputs, and now you can have, these happen to be 10 amp relays, but you can have much higher current run through these. And so these are the things that we're starting to discover. And so over here we've got one plugged in, and you know, you put your little circuit on a breadboard, and so this one kind of demonstrates the touch ability of this one of the sensors on here. So what you can do is, as I touch this thing, it'll start to light, and so it'll go brighter or dimmer based on how hard I touch it. So we've been playing with some of the different, they're called sketches, the programs that you write to have this thing listen on. And we've been playing with some of the sketches and how to get them to work, and how to tell things that, hey, turn the lights on, or turn the lights off, or turn these 3 on, or dim these. So we've been playing with a lot of that stuff. We've also been playing with some of like these sawn-off switches, which are, they're just super inexpensive. So these are super inexpensive as well. That's the amazing part about most of this stuff, is it's extremely inexpensive. I think I paid, I think, $70 for the Raspberry Pi, and that's because I got like the case and heat sinks and a special board and I think like a camera and the memory chip. Everything was included in this package that I bought. These ESP32s are about $10 or maybe $8, depending on where you buy them. These boards like this with a bunch of relays on them are about $10 or so, right around there. The Sonoffs kind of made a huge splash in the home automation stuff because they are about $6, and it has Wi-Fi and that enabled in this, as well as a switch. And so this made pretty big splash in the home automation stuff. Unfortunately, these are 120 volts, so our use of this is mostly just to kind of play around with it and see what everyone's talking about. But these, you can actually, there's tutorials online with how to flash your own firmware on them, because out of the box, you have to kind of register with an internet site, and then that internet site kind of controls this device. And so a nefarious person could, if they hack that site, then start turning things on randomly. You lose some of that control. So there is firmware that will flash these so that it remains kind of local and you can control these locally. All right, so we wanted to just introduce you guys to what we've been working on as far as bus stuff goes. And it may be a couple weeks. I also wanted to thank Travis. My buddy Travis on this thing has been helping me with researching and, hey, have you seen this? And so we've been kind of having this back and forth with a few of these things, and have you tried this sketch, and have you tried this sensor and stuff like that. So we've been going back and forth with this stuff, and so I wanted to say, hey, thanks for kind of geeking out on this stuff with me. But probably our next video is going to be us traveling to Mexico to go get the bus. So we're going to continue working on house stuff. There's a whole bunch of, anybody who's sold a house knows there's a bunch of stuff to do, especially when you're like, hey, we're going to move out and live in a bus. Like, you can't take all this stuff with you. So we've got to, we've got trips to Goodwill and all that kind of stuff that we've still got to do, as well as continue to minimize. We've been minimizing now for well over a year, but I mean, we've been married for 16 years and we just accumulate a lot of stuff. So we've been trying to slowly kind of purge and sort and try to go through all that stuff. So we have a funny video of our kids. I have been the PC repair guy for most of our family for as long as I can remember, since I've been in high school. And so I just had a cache of wires and old computers and motherboards and video cards and things like that. And so we did one weekend, we set out all the hard drives I had from everyone's old computers and our old computers and stuff. And I just said, rather than risk having someone pull some information on there that I had forgotten about, or credit card stuff and things like that, why don't we just have the kids like kind of go to town on the hard drives? And so we laid out all the hard drives and gave the kids hammers, and they just, so we'll post a video of them just like whacking away. They had a ball destroying the hard drives. So anyway, that's going to be it for this video. It's literally just an intro of what we've been working on, and we hope to bring you along to Mexico, hopefully within the next couple of weeks, and have a big bus reveal and show you guys how the paint turned out.